Yes.
Can I ask you a question about the quiz?
Yes.
All right, on quiz 10, you said what is the opposite of the operator less than?
Yes.
I put greater than, but then the answer is greater than or equal to.
Okay, so yes, we're going to talk about that today. Yeah, of course. So his question was the following. What is the opposite of less than? So to have an example, if we look at a condition x is less than 0, and so what would be the opposite? When is x not less than 0? And that would be the case if x is greater than 0 or if x is equal to 0. Because if x is equal to 0, then it's not less than. So the opposite of less than really is greater or equal. And it is a common misconception, which is why there's a quiz question on it.
All right, thanks.
Yeah. Okay. Other questions?
How do you get the class website? On the wired, you're on the wired network?
I'm on the wired network. So here on the wireless network, it's still not working? Okay, well, that's good to know, because then we'll have a specific thing that we can file a complaint against. So does anyone know elsewhere on campus? Is it also not working? It doesn't work in the library either. Okay, yeah. I filed a ticket, and we'll see how quickly they can fix it. I don't really know what great things I can do to deal with it. Yeah?
No question. So for the next exam, so how is the process going to be?
Well, the next exam, for one thing, I mean, it's going to be the same way, but presumably we will have this thing gotten to work. I'll also now have been savvier to stash away a backup copy of the exam somewhere. I mean, it's somewhat unusual that the internet works and justhorseman.com is blocked. Maybe one of you guys is working in the networking office and didn't want to take the exam or something. And as you notice, it's working fine here on the wired network. So it is some glitch somewhere in the wireless. The other thing is just make sure that next time, if you do bring your own USB stick, and it really does work in a case of total emergency to have everyone get one USB stick, make a copy, and then copy it onto two others. It's just like a chain reaction in a nuclear reactor. And after a few minutes, everyone has everything. And then it only happened once in my entire life, and I've been giving exams like this for over 10 years. So in that situation, the protocol would be that there's this copying phase where no one is allowed to do any work, and as soon as the copying has finished, then everyone gets to be allowed to work, so that there's no unfair advantage for those who have received it early. And really all it takes is someone with a sufficiently loud voice to announce the thing, and then it works. So I'm afraid that poor Sneekta just didn't have that, feel that she had that authority, and then she got intimidated when someone said that they were going to call the dean or some such thing. Yeah. A what? Oh, I see. I will be getting those, and I'll bring them to class on Wednesday. Other questions? All right. Let's get going with the lecture.
How was Java 1 for you?
Oh, Java 1 was great. Thanks for asking. So yes, I now know what's going to have to go on into the next edition of the book. A bunch of things are going to go away, like the graphics is going to all change. We haven't yet talked about interfaces, but the way people are going to be programming with them is going to probably change quite a bit in the next couple of years. So that should get exciting, because we get to throw out some of the old craft from the curriculum. Yeah.
So I know the next 4 series is coming out in November.
Somewhat?
The next 4 series is coming out in November. 4 books.
Yes.
So
Don't buy them. Those
they're
are
already obsolete.
yes. So don't buy them. Wait for the Java 8 edition of them, and they should be coming sometime next fall. You should be able to read them, though, for free if you go to the Safari subscription of the library. So that's actually a very good resource that you should be aware of. When you go to the library and you log in through, if you're either on the university or you log in with your password, you can read a whole bunch of tech books on Safari. And so when a book comes out for like 2 years, it's available on the university subscription. So sometime after December, you should be able to look at Core Java, for example, or right now it's Scala for the impatient, and hundreds of other good books. And it doesn't cost you anything. You just have to read them online. All right. We have two rates. All right, so we're finally getting into branch statements, and so the basic idea of an if is, kind of pretty simple. You have a condition here, if the amount is less or equal to balance, and then we do something, and if the amount is greater than the balance, then we don't do anything, and that way we can protect the bank account from being overdrawn. So the syntax is dead simple. You have the if with a condition inside, and then you have the action that you might want to take. What if you want to have a decision where you do one thing or the other? Then you use the if-else. And again, the syntax is very simple. You have the if, you have a condition. Here's the stuff that you do if the condition is fulfilled, and here's the stuff that you do when the condition isn't fulfilled. Now, if you looked over here, you notice that there was a single statement in the if part and another single statement in the else part. What if you want to do more than one action? And then the way you have to do it in Java is you have to use braces to enclose all of the actions that you want to do together. So over here, I might want to do 2 actions, and then I have to enclose them inside these braces. Some of you may know Python, where you use indentation instead for the same concept, but in Java and in many other languages, you just use these braces. Now, there's nothing wrong with using braces all the time. So over here, I could simply put a brace, and many, many programmers, in fact, do that. And it's a perfectly good idea that it's just a good habit to have. Just always use the braces. There's no harm in having too many of them. So if you like that style over here, what you then would have done is put a brace here, put a brace here, put a brace here, and put a brace here. And it makes the code look a little bit longer, but that's just fine. All right, just as a terminology, we say that a statement is something that is a unit of work. For example, here, this is an assignment. And you can see it's a statement. It ends in a semicolon. Something that doesn't end in a semicolon, such as balance minus amount, in contrast, is called an expression. So that's just a technical term. An expression is something that has a value, something that does some kind of computation, and you can combine simple expressions into more complicated expressions. But it's not yet an entire unit of work, whereas a statement is an action, something where something happens. Here you have an assignment statement, and it does something simple. Here you have a more complicated statement. It's what's called a compound statement because of the condition. If this condition happens, do something. So that thing together is called a compound statement. And finally, you can take any number of statements, put a pair of braces around them, and then the whole thing together is called a block statement. So that's just terminology. That way we can say that the body of an if statement is another statement, which could be a block. Yes?
So when they said that we shouldn't try to put decrements or assignments in an if statement, they mean inside those parentheses, right?
Yes. So what they mean is inside here, you should put an expression that evaluates something in such a way that that evaluation doesn't have any effect. So you shouldn't change anything. So that way, if you were to ask the same question again, in other words, you would still get the same answer. Yes?
What if you were to do that and then reassign it inside the same?
Oh, that's fine. In fact, we do that over here. So if you look over here, we're testing is balance greater or equal amount. Is there enough money in there to handle the withdrawal? And then over here, inside the body, we change the balance, and that is entirely fine. The only thing that there was a rule in the book, the only thing is that in the test, in this part here, you should not mutate anything.
Said sometimes it's useful, but it's very
It
rare.
is rare, and it's generally considered confusing style. So if you can avoid it, and you can generally always avoid it, you shouldn't do it. And so the reason is that for the human mind, one thinks of this test as something that that should give you an answer, a yes or no answer, and it should not. That answer shouldn't have any other effect. It shouldn't cost anything to do that. It should just you just want to know what are the facts so that you can drive the decision on that. All right. Here we have those operators here that you just asked about. So there are 6 operators that you need for comparing values. They're the same ones that you use in math. Greater, greater, equal, less than, less equal, equal, and not equal. They are written in a funny way because the keyboards don't have convenient symbols available. This is actually something that may at some point change. When these kinds of languages were first invented 40 or 50 years ago, there wasn't any way of showing all of these symbols on the display. The display had a fixed set of hardwired characters that they could draw. Nowadays, of course, you can draw any symbols that you want, and newer programming languages are becoming available where you will see inside your IDE, inside NetBeans or inside BlueJ, for example, you would see the symbols in the more pleasant, conventional way so that you wouldn't have to retrain your eyes after having had 12 years of mathematics, where you always saw the symbol this way, and now you have to remember it looks this way. That may go away at some point in the future. There's still the question, how do you type them in? We'll never have a keyboard with 5,000 keys, one for every character. And so it's conceivable that one would type it in like this and later see it like that. But that's still pie in the sky. Today, the way it still works is that in Java, we see them in this slightly uglified way, and you get used to it. Now notice equal, equal versus equal. So when you do inequality testing, you have to remember to do the equal, equal. Because the equal has previously and foolishly by the language designers been taken for assignment. So equal means we're going to make them equal by assigning the right hand to the left hand side. And then they ran out of symbols. Then they had to come up with a different symbol for equality testing. That's actually unfortunate, and it's not the fault of Java. They just inherited that from another language called C. In other programming languages, they were smarter. They said, well, equal has been used for 200 years in mathematics for equality testing, and then for assignment, they made another symbol, a symbol that might look like this or like an arrow. And that was actually a better setup. That way people could have used their mathematical intuition. One of the first programming languages that's now, 50 years old, called Algol 60, did exactly that. And so it was 50 years ago. This was, a year after I was born. So it's amazing. And the C people, for some reason, didn't know or didn't care about it. And a famous computer scientist once said that Algol 60 was a great improvement not only over its predecessors, but also over most of its successors. And this was very true, and this is one of the examples of that. Anyway, in Java, we're stuck with it, and it soon becomes second nature to watch out for equal for assignment versus equal, equal for equality testing.
So another exclamation point. Not, right?
Yes, so as you'll see in...
Exclamation point, put it in front of a less than sign.
No, you can't do that. So that's a good question. Should they have introduced not less than for greater or equal? They didn't. I mean,
Wondered if it would work.
no, it will not work. It would have been a rational choice. But then again, maybe from a user interface perspective, given the confusion that we've just seen, maybe not. So they didn't do it. So for not equal, they've used this symbol. Other programming languages write a not equal as a less than greater, which might also make sense, but Java does not do that. So you just have we just have to live with these symbols that were given to us. They may not be the most elegant, but they're certainly usable. We can speculate on this. Now, why didn't they use slash equal? I mean, that would have looked more like a not equal sign, but they didn't. All right. It's convenient and pretty intuitive, just like in mathematics, that when you have a comparison of two things, then you can put arithmetic operators on either side of the relational operator, and they come first. So first the entire left-hand side, then the entire right-hand side is evaluated, provided the left and the right-hand side contain just arithmetic operations. So the way we say that is that the precedence of the arithmetic operations is higher than that of the relational ones. And that's exactly like in mathematics. No big deal. All right. So now let's see how I can trick you. So here's a series of trick questions today. Let me start Piazza. I'm going to leave this on since I realize you can't be reading it, but I do need to go into Piazza real quick. So those of you who have a smartphone, you should be able to go to the lecture, by the way. I tried that when I got those frantic calls and worked fine. Yeah. Yeah, I'm putting it. Yeah. All right, so if the amount is less equal the balance, then let's say the balance was $1,000 and the amount is 500. Then that's okay, right? Then 500 is less equal to 1,000, and I should be able to get into the loop. All right, so let me just write this down. So balance is 1,000, amount was 500. So then I compute the statement, the body of the loop. So new balance is, well, that's even a syntax error, right? I never declared this puppy. All right, so that was a problem. Now I'll declare it. And so now, just a second, now balance becomes 500. Or does it? No, new balance becomes 500, right? Balance hasn't changed yet. So new balance is 500. And then balance is new balance. Wait. What? I don't think it would even compile, because what would now happen? I really need the braces. So the upshot is I really do need the braces to group these two together. Without the braces, the whole thing is not going to work. So this is an example where the indentation is misleading. I say it wouldn't actually compile, because if you just put the int here, then then the body would just be this single statement, and new balance would be local to that, and you couldn't even use it outside. All right, so the answer is definitely the something else, and that's you need the braces. So the logic of the less than was correct, or less than versus less than equal. Let's just actually think why one is wrong, just to make sure, because that I think was the most popular other answer. What happens if they equal? What if I have $1,000 in my account and I want to withdraw $1,000? Can I? I can, and I should be able to, right? I mean, you would like to be able to go to your bank and say, give me all my money. And if they say, well, you have to leave at least a penny, that would be a little weird. So it should not be less than, it should be less than or equal. It's a general issue that when you write these conditions, it's often tricky to decide whether it should be less than or less than equal, or conversely, greater or equal versus greater. And the easiest way of making such a decision is to construct a simple example, like what I just did. What if I have $1,000 in the account? Can I walk up and say, give me $1,000? Now, of course, you can reason from general principle. You can say, I should be able to take the entire balance. And if that's easier for you, by all means, go ahead. But most people find it easier to reason from an example. And a well-chosen example is perfectly fine in this case. So I'd always encourage you that if you want to test out, should it be less equal, should it be less than, make a simple example and go from there. Yes?
Would you be able to, say, put balance minus balance as your withdrawal?
Balance minus balance?
Yeah, I guess you would be able
That's zero.
You would be able, yeah, I'm just saying you would be able to input that.
No. All right. Floating point numbers. So ever so often we have to deal with round-off errors. So here is a typical example of where round-offs could be confusing. I'm computing the square root of 2. Then I multiply the square root of 2 with itself, which mathematically should give me the number 2 back. And then I subtract 2. And it surely should be the case that the square root of 2 times the square root of 2 minus 2, that should be exactly 0. I mean, that's what you've learned in mathematics. But because of round-off, it's not exactly 0. When you check, is it 0, then this test will fail. So the test for equal 0 will fail. It will not print square root of 2 squared minus 2 is 0. It'll instead print square root of 2 squared minus 2 is not 0, but whatever. And the whatever is going to be this tiny quantity, 4.4 times 10 to the minus 60. Now, what does that mean for, for you? When you compare two floating point numbers, in this case we're comparing the quantity d and the quantity 0, it is not good enough to use equal equal. Equal equal does not work with floating point numbers. So instead what you have to do is you have to check whether the two numbers that you want to compare, whether they are close enough. Now, what does it mean to be close enough? So if you're talking about like regular dollars and cents kind of thing, then close enough is pretty intuitive. But now suppose you're trying to estimate something, say, the volume of the planet Jupiter. And now you're off by a few thousand liters. I mean, that's still close enough, right? Because that's still well within round off. So one can't in abstraction say what it means for two numbers to be close enough. It depends on context. And so most of the time we compare numbers that are like pixels or dollars or something. And then a fair comparison would be if I subtract the two, and if the difference is less than some small number here, I've chosen 10 to the minus 14, then the numbers should be identical. So if you look at the test over here, that would have handily passed because 10 to the minus 16 is 2 orders of magnitude smaller than 10 to the minus 14. It's 1/100th of that. And so they would have easily been less than 10 to the minus 14. But you have to choose that constant depending on what the problem is. So if the numbers you're comparing are each astronomical, then you might have to make a different choice. So what's with the absolute value? Well, if you have like a number like 1.00001 and you compare that against 1.0, when I take the difference this way, then of course the difference is 0.0001, some tiny number, and life is good. But if I have it the other way around, where it just happens that my first number was 1, and then my second number is 1.00001, then that's a negative number, and I want the comparison to go the same way, so that's why I take the absolute value. In Java, the absolute value is written somewhat unattractively as math.apps, so the test in general would look like this. So when you see a test like that, that tells you we're trying to find out whether x and y as floating point numbers, whether they're almost the same quantity. And so generally, when you compute with floating point numbers and you need to make that comparison, you always want to do it like that.
Looking for us to use the epsilon test for our bugs?
Yes, oh, absolutely. So now so that brings a good question. When you have a tester, you could have a test where you would write system out print on, and now you would put this entire thing in there, math.apps of x minus y less than epsilon. And then you would have to, for the expected testers, also say system.out.println expected true, because that statement will print true or false, and then you would say you expect that to print true.
Well, I meant it for like the actual the bug.
Oh yes, you can do that in the bug. I'm not sure in the bug code there was any decision that we needed to make, but
Well, there was sometimes like x will be like that really tiny number.
right. But that's a question of what happens in when you print out the values, and they'll be a little bit off.
Because it'll turn and then it'll all of a sudden adjust its x value like a tiny bit.
Right. And so if you're testing for it, in a tester, you can use this expression. You don't strictly have to do it because NetBrat is smart enough to make that same test internally. But you could, and that would make your tests come out a little cleaner. And we will eventually have some variations of that bug where we want to see whether two bugs meet. Are they on the same location? And of course, they'll never be exactly on the same location. One would have to test whether the distance between them is quite small. So with integers, comparison was easy. With floating point numbers, it was completely different because we have to take roundoff into account. And sadly, with strings, it's also different again. So it would be tempting to use the equal symbol to compare two strings. And without wanting to go into the details why it doesn't really work, I'm just going to tell you it really doesn't work. And the compiler will not alert you to it, unfortunately, but it is always a mistake to use equals to compare for strings. Instead, you need to use a method called dot equals. So let me just briefly demo this so that it becomes believable. BlueJ. My hands on. BlueJ. There we go. BlueJ. Yeah, so I met the BlueJ people at that conference, and I told them we only have one wish, and that is that they should make this thing here bigger. So here I'm checking whether the string that I've stored into hello is the same as hello, and it'll say yes. Now I'll take a substring here, and let me put it into a variable. And I'm going to check whether that is what you've just seen it to be, namely HELL, and the answer is no. But if I ask it, does it equal HELL, then the answer is yes. So what you can see from there is that equals is unreliable when it comes to strings. Sometimes you get the right answer, sometimes you get the wrong answer. And unreliable is fatal in computer science, right? There's no use for a test that sometimes gives you the right answer. And if you've learned anything in the last few weeks is that, sometimes it works, it's just never good enough. So I could explain to you why this is the case, but I'm not sure it would do any good. Because the simple thing you simply must remember is you cannot use equal with anything other than integers, really. It is not useful for objects of any kind, for rectangles or anything. We're going to talk more about that next semester, but for right now, just use equal only to compare integers. Don't use it for floating point numbers. Don't use it for strings. For strings, you have to use the equals method. And it's a little sad that the equals method is more tedious to type. So you could also test whether two strings are the same except for upper lowercase, but that happens pretty rarely. Okay, lexicographic ordering. This happens sometimes when we want to compare two strings to see which one should come before the other. So let me just try a couple of strings. So compare to. So I've just compared cat and cats, and it says in the dictionary you would find cat before cats. And so if we compare cat to dog, then the -1 again says that in the dictionary the cat would come first. So let's compare dog, compare to bug. And now it's 2. So the way it works is that it doesn't matter what the value is. What matters is whether it's positive or negative. So if compare to returns a positive value, then that means that the thing to the left of the dot should come after the thing inside the parentheses in the dictionary. If it's a negative value, and it doesn't matter what negative value, then it's the case that this one here comes before that thing in the dictionary.
Is there any meaning to that?
Yes. So what it actually does is, because it turns out to be, it does a tiny bit faster to run, they take the difference of the characters. So if I were to compare cat, compare to, and now I'll take, say, CA, like a B. Then what I'll do is it'll compare the C against the C, they match, compares the A, they match, and then it computes the code for T, subtracts from that the code for B, and if that difference is negative, it just returns that value, or if it's positive.
18 letters away.
Yes, it's 18 letters away. So that's what it is. It's not something that, so it's the, it is how many letters the first non-matching letters are away from each other. It's not something that one ever wants to know. You always check whether it's less than or greater, but that's what it is, just in case you want. Yeah, so also notice that in the ordering, all uppercase letters come before all lowercase letters. So the Java dictionary is a little bit funny. You would find the word hello before the word car or cat because it starts with an uppercase H, and all uppercases come before the lowercase a, which is not terrifically useful, but that's the way it is. Okay, comparing objects. So we're not really going to do it, so I'm not really going to say too much about it. That if you have two objects, like if you had two rectangles, and you wanted to know whether they contain the same stuff, then you would still want to use equals. So let me demonstrate this here. So here's box 1. Here we have. So now I'm going to ask, is box 1 the same as box 2? And it's going to say yes. They, after all, have the same numbers in it. Is box 1 the same as box 3? And indeed it is. Is box 2 the same as box 3? And they sure are. But now let's try the same thing with equal, equal. Is box 1 the same thing as box 3? And the answer is no, because they're distinct objects. So when you look at the code here, over here we have a variable box 1. So it points to this little blob here of that first rectangle. We now have box 2, and they point to the same thing, because when you make this assignment, you just copy over the addresses. Now box 3 was hooked up to a newly constructed different rectangle. They have the same numbers in them. They both have the numbers 5, 10, 20, 30 in them. So they are EQUAL, but they are physically different objects. They're located in different places in memory, so they're not equal. All right. Another comparison that one sometimes makes is null. Sometimes it's convenient to distinguish between a variable that has never been set and versus one that has been set to something. And so the value that you can use for saying this thing has not been hooked up to any object at all is called null. It doesn't really have much to do with the number 0. And of course, it has no letter with it in common, so that's okay. Null simply means there's nothing attached to it at all. So remember how we draw these diagrams, we have the variable, and normally the variable points to some object. But if it's null, then there is a special value called null stuck in here, and it doesn't point to anything at all. And so over here I have a situation where I have a middle initial, and I want to make use of the fact that some people don't have a middle initial. And in this case, I would set the middle initial to null, and otherwise I would set the middle initial to something. And now then I can test for that. So here's a typical example. Middle initial is null. In that case, I print the first name and the last name, and otherwise I print the first name, the middle initial, and the last name like this. And so I use equal, and here it is legal to use equal in the null comparison, and not equals. And it is not the same thing as the empty string, and that's what's often confusing to students, that they both sound very empty. Now let me demonstrate that it's not the same thing as the empty string. Suppose, you would say, this is kind of stupid. Why don't I just make it so that inside middle initial, I put an empty string whenever someone doesn't have a middle initial? So do we know anyone who doesn't have a middle initial? Okay, neither do I. There must be someone. Joe Smith. We all know Joe Smith has no middle initial. So now, let's say we were to represent the middle initial then with a space. What would this actually then print? Not as a space, as a blank. Yeah, it would print this space. Then it would print the dot and another space. I'm putting quotes around so that we can see them clearly. And it would say Joe space dot space, and that wouldn't be very elegant. So this is a good example where it's kind of useful to be able to say that something is nothing at all, and not even a space, not even an empty string, because for the empty string you would still get the surrounding stuff. So every once in a while this null thing comes in, and it's useful. All right. Okay, let's move on to this clicker question. Oh yes, this is a great question. Okay, I'm gonna have to make it a little smaller. Yeah. Okay, here we go. A moment. Piazza. Yep.
On Piazza, I posted a Google Cache for the lecture slides so that people can go there and see.
Oh, great. Yes. Oh, excellent.
So that's a way to get around the blog.
Wow. So everyone just go to Piazza and click on this link here, and that way you should be able to see the lecture as well. That's a great way of doing it. All right.
Apparently they just blocked it because everyone's going.
Google blocked it?
No, I think SJSU probably did.
fact that
May-
everyone went there just blocked it.
Great guess, yes.
Maybe early retirement is in the stars here.
Oh, let's Google that blocker.
Okay. Yeah. Well. So it's syntactically incorrect, it means it wouldn't compile. All right, let's see. So the first one. Okay, that one syntactically okay. That one seems okay. That one seems okay. That one seems okay. Can't find B. Just told what B is. Let's try it again. Okay, well, it compiles. Can't find X. What gives? I think I have to paste these one line at a time. Okay, so we were A equals X. Ah! That one is syntactically incorrect. It says incomparable types. One is a string and the other one is an integer. You can't compare them. Even though when you look at it, you know, A has a number 1 in it. It doesn't matter what it has in it. It's a string and that's all that counts. So you can't compare strings and integers. They would be like apples and oranges in the world of Java. You can only compare things of the same type.
If you use the parseInt method,
Yeah, you could. Then you would convert it, right? So you could do integer.parseInt, and then you could convert it to an integer, and then you can compare them.
parse double.
Yes, and it's called double.parseDouble. Let's see, x equal y. That's true. Let's see if the difference is. Aha, that's incorrect. Because on the left you have an integer, and on the right-hand side you have the quantity null, and null is an object reference, and it's not the same as the number 0. And then finally, that one is also not correct. Why? What's the type of x? Look over here, you see the type of x is a double. And in Java, numbers are not objects. And so it's not legal to say a number dot anything at all. You can invoke methods only on objects, not on numbers. Just the way Java is. All right, so we found 3 incorrect ones. And now let's see how many questionable ones we can find. This one here, questionable, because we're not supposed to use equal with strings. This one here is fine, so one questionable. This one is fine because we might want to know whether A is null. This one here is fine, it's good to use equals with strings. Over here we have another use of using equal with strings, so that's bad. Over here, that one didn't even compile. Over here, x equal y, that's questionable because we're not supposed to use equal with floating point numbers. So that means 3 incorrect, 3 questionable. Let's see. And so that was the majority answer, but not by landslide. So just have a look at that. All right, well, that brings me to the end of what I need to talk about with 15 minutes to go. I can talk about the homework or I can talk about the exam. What do you want to talk about? Yeah? I'm sorry? This one? Further down? Yeah, someone said they had the same. All right, let me have a look at this. No, that's the wrong homework. Oh, yes. Okay, so let's talk about this one here first in general terms for a couple of minutes so that everyone sees what we're up against. This is a beautiful assignment. So we have the outline of this box that the bug lives in. Originally, the bug is in the middle, and now the way it moves is in diagonal lines, so it can move. Come on. It can move here in any of these locations. And eventually, you're going to be in a situation where it might move in some zigzag here, and now it comes to here, and now it's at the boundary and needs to reflect itself at the boundary, which means that next time you need to come over here. So what that means is here we came in with a vector of, actually, we have a perennial problem. We have to figure out which way are our x's and y's going. So the x's increase in this direction. In which direction do the y's increase? Is it downwards or upwards? So the question we need to ask ourselves is, in this particular example, in homework 3 part C, did that bug live on the screen, or did it live like in regular old integer coordinates? So let's pull up that assignment. Now over here, when the bug moved down, you notice that we have a dy of -1. And that would suggest to me that over here we have a regular coordinate system where the y's move upwards. So we want to follow the same convention. Now this is a headache that one has every single time that one deals with the y-axis, because it's just different in the regular world and inside the world of the graphics. So the x's go this way. Just a little bit side. The x's go this way, and the y's go up like that. So that means that the vector that I had over here, this particular vector, was dx is -1 and dy equals 1. And that was before reflection. And then after the reflection, and that's the reflection now on this horizontal axis, afterwards it got turned into dx is still -1, and now also dy is -1.
So basically when it hits the wall, it rotates 90 degrees.
Does it though? It does not rotate 90 degrees.
It actually kind of goes backwards.
It gets reflected. So it gets reflected along that mirror. This is what you remember from, what presumably they told you in physics sometime, right? They said incoming angle equals outgoing angle, and now it's a 45-degree angle, so the angle is the same, but it does get reflected, and a reflection is not the same thing as a rotation. And then you can't compose a reflection out of rotations either, because rotations don't change the orientation. So if I rotate myself, then the left-hand side and the right-hand side of my face don't get changed. But reflection flips them. And so it's a mathematical fact that you can never compose a reflection out of any number of rotations. The other thing actually is true. You can take two reflections and they can be composed to form a rotation, but that doesn't do us any good. So that means you can't simply use turn. So turning 90 degrees is not going to work. It's going to do something different. And so we can actually see that. Let's say the bug were to now turn. Okay, let me put it this way. So let's say you would adjust to, say, turning 90 degrees. And now we try to use the same rationale here. Then it clearly wouldn't work. It would have to go this way. So, so when you're on this board here, then you have to come this way. When you come this way, I guess you could never hit either of these two coming in this direction, right? So when you're moving towards the north, whatever, northwest, you can only hit these ones here. And so this entire assignment was, of course, constructed to give you ample opportunity to use if-else, right? You have to distinguish a bunch of cases. So what's important to realize here is that there's no one formula that is going to work for all directions and all walls. You have to come up with some way of splitting up the search. And now, having beaten upon rotations, maybe I'm underselling the rotations. You could do the following, and I hadn't thought about that. You could say, I'm going to have 8 cases. 8 cases isn't bad. You're going to have 8 cases, namely 1 for each of the 4 directions, and each of them splits apart into which of the 2 walls you could be hitting.
I tried doing that, and it was really long.
Yeah,
I kind of messed up, so actually I didn't.
but you could do it. So let me go all the way through with the 8 cases. If you did the 8 cases, then for each of the 8 cases, you could actually figure out how do you make it work with turn. Because you would say, in this case, it means a turn by so many degrees. In this case, it means a turn by some other degrees. And you could draw 6 more diagrams like that, and you would be able to have a complete mapping of the 4 directions and the possible walls and the turns that have to come out of it. If you don't want to do that, and I didn't want to do that, it does help to know a little bit of math. And so here's the math. Let's look at a reflection along a vertical mirror. So you come in, with a vector that has a particular dx dy value. And then you come out again like this. Now, when you look at it, the displacement in y, this one here is dy, and then this one is the new dy. They are the same, right? They're exactly the same. Whereas the dx, this one here is the dx. Not so easy to write a mirror image. This one here is the new dx. And so, they're what? It's just the negative of each other. And if you think about it, it doesn't actually matter whether you come from this side or whether you come from this side. Either way, you have the translation that on a vertical mirror, the dy doesn't get changed and the dx gets flipped. On a horizontal mirror, it's the exact opposite. That here the dx and the new dx are the same. The dy then has to be flipped to become negative. So now that means we've reduced it down from 8 cases to 2 cases. You simply have to check, am I hitting a horizontal wall or am I hitting a vertical wall? Yes?
I don't have it in front of me, so maybe you said in the problem statement, but what do you do if you go into a corner?
Okay. So that is admittedly another case that I hadn't talked about. What happens when you go into a corner?
Actually, I found out how to solve this. If you do your if-else statements for dx and dy separately on the move,
Yes.
then it'll handle that problem.
Yeah. Let me first of all make sure that everyone realizes what happens in this case. When you go into the corner like that, then you come out completely backwards, So in this case, you need to invert both the dx and the dy. And so when I first coded it, I said, gosh, there's another 4 cases that I need to deal with. But then I had the same observation as the fellow here in the front who said that if you cleverly arrange the if statements, it can be possible that case comes for free. But I would say, if it doesn't come for free in the way that you're coding it up, that's okay. Just handle those cases. There's 4 possible cases, and in each of them the action is the same, meaning the dx and the dy are both flipped.
It's just you treat it as if you were getting both ways.
Yes, and so really, if you cleverly arrange it just the right way, you can get this as a freebie. But if you don't beat yourself up over it. Make sure that you have a test case for it, and make sure that it works, and that's all. So, so the whole point of this assignment was to put you in front of a situation that has a bunch of decisions that need to be made, so that you can see why the if statement is useful. And the other one is to give you an assignment where it really pays off to first write down on pencil and paper what should happen. I actually tried to code this on the train, and after 10 minutes I gave up and said I'm not smart enough for this. And so I figured out what actually needs to happen, and then it was smooth sailing. So I don't, let's see, go back to what the Piazza thing here says. Well, okay, nothing that I'm in here looks even familiar. Okay, but this is actually great. So, so please, no offense that I'm pointing out issues with code. First of all, see, so that we can see the error and not so much the name of the person. Okay, I can't. Sorry, I can't hide your name. It doesn't scroll like that. So what's So here's some 2 interesting things are happening, and they're both worth discussing. Number 1, what's wrong with method X? Well, I would just question the name. So nowadays that you're going to be needing variables more often, you don't want to have confusing names. And so if you name a variable method X, it really is confusing because it's not a method. What he wants to do, and that's very reasonable, is he wants to get the current X and Y position. So, what's wrong with saying int X equals get X? That would be just fine. Or if you think X is too short and someone told you not to have short variable names, you could say int current X equals get X. That would be a better name than method X either way. This happens extremely often that when people name the variable the first thing that comes to mind, and it's something that you want to watch out for. Now, but more fundamentally, this is inside the class bug, bug 4. Was there any need to call getX? No, because in the bug, it remembers its current X and Y position in instance variables X and Y, and you can just reference the instance variables, and that'll make the code much simpler. Now then over here it tests whether method Y and Y are the same thing, whether it's the same thing as, what's wrong with this variable name? Yeah, why is it capitalized? Is it a constant? Now, that's possible. It might be that in the context of what, because we don't have the entire code in front, this might be the size of the box. Is that a constant or is that another instance variable? I think that's passed in the constructor, so even that would not be a constant. No, it's passed in the constructor. Yeah, so that's puzzling why this would be uppercase. And you really, really want to be careful about that uppercase, lowercase convention. it is confusing to the reader, and when you get a snippet of code, people really expect variables to be lowercase and constants to be uppercase. So let's assume that this was the instance variable y. So now in this case, we're testing, comparing y, and we're comparing y plus 2 minus 1, and we're checking whether they're the same. Can they ever be the same? Yeah, it's a linear equation, right? It has exactly one solution, at most one solution, I should say. Yeah, so if y is 1, then they happen to be the same. So at this point, there's got to be something that is seriously not quite there with the code, and I would have to advise the author to go back to the drawing board. Now, this is right around the time of the class when I see that an awful lot, that people will go down a rat hole and not go back to the drawing board. So when you find yourself in a situation where the code that you start writing doesn't make a lot of sense, pencil and paper, and try again to figure out what the problem is. All right.